Welcome everyone to this industry panel. And this one today will be about societal use of digital twins. And we have 4 participants that are here today, and then they will present to you. The industry panel will work like this, that we have approximately 1 hour 40 minutes. So we will stop at 6:10, not 6:30. That is by accidentally written in the program. So 6:10 is the hour when we finish. And we have divided this 1 hour 40 minutes into 2 slots. So first we will start with presentation. And we have 4 people here representing different perspectives from industry. We are super happy that you are here. We will have a short presentation by each one of them, being like 10-15 minutes. So that will be the first part of the industry panel. And then we will open up for discussion. So I will call all of you to come here, and then we'll have some questions, and we'll have a bit of a discussion about societal use of digital twins. And then in the end, the last, let's say, 30 minutes, we will have open up for discussion. So if you have questions, or if you think of anything while listening to these presentations, just keep that question in mind, because there will be an opportunity for you to pose questions to the panel. So with that, we are ready to start with the first presentation, and that is by Magnus Melin. And Magnus is from Scania. And even though you are Swedish, you represent Scania China today. Magnus, he's the head of Scania's Innovation Center in China that is based in Beijing, if I understand correctly. And this center is also Scania's global research and innovation capability, and you work on different aspects, among other the smart city. You provide products and services to China's customers in China and throughout the world. So very welcome.
Thank you. Thank you. So a short history lesson from my perspective is when I arrived in Shanghai 5 years ago, more or less on this date, or this week actually. My first impressions were, oh my God, I have landed in the future. Because that's what it feels like. You have a city that is bending over you with the skyscrapers, and everywhere there is these modern structures that feels like you actually have arrived in the future. But there were one issue though, and something that I reflected about immediately, which was, oh my God, the traffic system is a mess. How do they keep this in order in any shape, sense, or form without it exploding in the very near future? So that was my first day in Shanghai. I have visited China many times before, but never in this super metropolitan area with 20 million plus citizens. Today I will try to connect what in China is called smart cities with digital twins, which sometimes also is called digital brains, depending on who you talk to, or city brains. And in order to do that, we first need to start with the definition. And China as a country has its own formal or official definition, which is in a simple translation, where we mix core technologies like IoT, cloud, big data, and other information and communication technologies. We can also extend this and say some smart infrastructures also contain charging, battery swapping, and other types of new energy, renewal of new energy like hydrogen and other things. Why is it so important to have this smart city or digital twin infrastructure? Well, in most of the areas in China, when we talk about the Beijing area where I reside, I also work a lot in Shanghai, we talk about the area that is Beijing, Tianjin, and Hebei, about 100 million people. We talk about the Yangtze River Delta, which is Shanghai, Hangzhou, Suzhou, also 100 million people. And if we talk about the Greater Bay Area, which is on the map, if you look at Hong Kong and look a little bit upwards, we also talk about 100 million people. In order to handle these type of enormous populations with all their requirements and demands. Transport needs to be optimized, and it needs to be constantly optimized in order for these cities to work, because they haven't stopped growing. All these figures that I also mentioned now with the population, they are estimates. No one actually knows how many people live in Shanghai, because there's a lot of people living there that shouldn't be there. There's a lot of people living there that are not taxed there. So it's a huge dark number that we don't know about. So he's driving the smart city and the digital twin development. Usually the different governments. The central government usually sets the framework, and then the local governments, provincial governments adapts it, and then the city governments implements it. And it's all the way down to actually on a street level, which is more the block in the city. I would say that the cities that have come the furthest, both when we talk about smart city and the digital twin or the digital brain, would be Shanghai. But today we are going to deep dive into Beijing, because that's where we have done the most research. I also want to just emphasize on how we connect this, so you don't feel disappointed when there was this guy from China only talked about smart cities, but you were promised digital twins. So it's more like the bridge between, and I don't see a difference. That's why I would have a hard time to separate these two if someone asked me to do so. It's more like the digital twin and the smart infrastructure. It complements each other. So in a simple term or on a conceptual level, the smart city feeds the digital twin with data. The digital twin feeds the smart city with a solution. Very simplified. And I also want to mention I'm not an engineer, so if there are tough technical questions later, I might have to redirect you somewhere. This gives us, or it gives the government, a holistic view of everything from how is the city working right now, and what can we do to optimize and improve the different flows in the city area. Helps with urban planning, helps with operation, and it helps with management, of course. Today, when we look at Beijing, which is also an enormous city with 22 million in population, it's old. And I mean this in a good way. They have kept a lot of the old buildings. It's not the same feeling that you can when you step out in Shanghai, that you're overwhelmed by the future. But it feels a little bit old. But number one in Beijing is and always will be safety and security. Because to exaggerate a little bit, you can say that the whole country of China is constructed to protect Beijing from everything else. It's built around mountains. It's a very strict security enforcement as further into the city center or on the two axes that unites at the Forbidden City. You will not get near that if you're not very careful when you navigate Beijing. What else can we say about Beijing? When I say 22 million, the same logic applies as Shanghai. That's what we know, and that's what we know from the tax records. There are many more people living in Beijing than 22 million, that we also know, that are not registered in any way. A thing that is a little bit different, I see a few Chinese faces here, but so excuse me if I exaggerate a little bit, from European society and Chinese society, that everything drives toward convenience, which makes transportation and the transport ecosystem even more important to optimize. Not only the large shipment from overseas into the bigger city areas, but also on a micro level down to block and distribution back into your door. I tell my Chinese colleagues or friends that I go to a post office in Sweden, stands in line for 30 minutes to collect a package, they think I'm joking, or even worse, they think I'm insane. So what can we do with the smart city technology? If we look at Smart Beijing, there is a very clear direction from the local government. They talk about a vision that is eco-friendly, it should be green, it should have high quality of life, it should be a hub for innovation. But they also put a lot of investment and a lot of action behind these words. So in the planning, which is public to anyone, you can find the 5-year plan for smart Beijing, and you can also interpret it until almost 2035 and say, okay, this is what will await for us. Just to quantify a little bit what we talk about during 2024, the investment level is about 50 billion RMB, which is about 6.5 billion euros. And on the absolute shortlist for the rest of the year is interesting things like changing the different traffic lights in the downtown area, because rumor has it that most of them actually are manually controlled by a person today. But that one they want to feed from the smart city infrastructure to be able to control traffic flow all around the city. One other thing about Beijing as a city, it is very congested and the traffic is a huge problem. They have tried to minimize that, but the actions that they have taken, that you're not allowed to use your car more than 4 working days per week, and some other also issues. It hasn't worked out that fine, because there's also enormous wealth in Beijing. So if you're not allowed to use your car one day, then you just buy one more car, like we always do, right? If we talk about other things, and we will come into how this will affect Scania and the transport company in general as a more specific, and spend the rest of the time on that. But I just wanted to somehow visualize this for my own sanity maybe, and just say, okay, what is a digital twin or a digital brain, and what is a smart city, and how do they interconnect? Took 6 different areas and talk about real-time data and simulation and planning and development. Also, citizen engagement is very important, and resilience and sustainability. One other thing that we could also mention in this context is that depending on what your objectives are, a smart city and a smart city infrastructure together with the digital twin is very good to keep track of people, because you don't only know where they are, you also know where they're heading, which could be good in different ways depending on what you want to do with that information. So, what should we do, and what should we focus on if you are a transport company? If we would say the following, like, these enormous cities and these infrastructures, they are the hubs of economic activity and urbanization. So, from a business point of view, as a transport company or as a transport provider, we need to be in these areas. We might not be able to have all our products running around in the full city of Beijing, but we need to understand what is going on, and this is where the business happens. Long term, it might be, we might end up in a scenario where it's a prerequisite for all the transport OEMs or other types of transport companies to be part of this, both smart cities and digital twins, in order to simulate and emulate what actually is going on in the transport ecosystem. They might not be option to not be part of the smart city. And since the government is controlling this and it's kind of secretive, we have a hard time being that. So it's something that we're also working on and thinking about. Other things, we at Scania, we are the leaders of sustainable transport. For us, green mobility is number one. This will help us to enable that. So, of course, we want to be part of that. I would also say, from a personal perspective, I work with innovation. When we have all these enormous amounts of data, when we have this possibility to copy or replicate the city, of course, we want to be there also to innovate and find new solutions. I think that's my time, right?
Yeah, that's it. That's perfect. That is perfect. Thank you very much, Magnus. Thank you for sharing your view on smart cities and what you're doing on that, and also the view from a transportation company. The next speaker is also from a transportation company, but from the aircraft industry, and he's Kenny Swope, coming from Boeing, the USA. And Kenny, he leads the Boeing supply chain collaboration and enterprise interoperability standardization team in Seattle, USA. And I know that you're also very active in the International Standardization Organization, and among other things, you...
Wrong presentation.
Yes. And among other things, you lead an advisory group on digital twins. So we look forward to learn more about aircrafts and digital twins and standards.
All right.
Yeah, welcome.
Thank you. And thank you for having me here today. I'm really inspired by the focus on transportation. It resonates with me, especially what's happening in China as we talk about not just the transportation infrastructure on the ground, but also in the sky. And one of the things that I work on as part of digital engineering, which was what we kind of call our advanced technologies at Boeing, is how do we represent the products and services that we use in our business to help enable those of you that are in your business. For example, if you're a customer or if you're a supply chain. For the past several years, of part of my 30-year career at Boeing, I've looked at the role of interoperability at the data level. So one of the things that I do as part of my job is look at how we produce data, especially in particular engineering data, and how that engineering data is used as an enabler to other domains downstream in the full life cycle view. So one of the things that we'd like to talk about when we think about digital twin is how is this different? In the aerospace industry, we have a reputation for pioneering, if you will, some of these technologies that we now talk about and call advanced modeling and simulation. A little tidbit, in the 1950s and 60s, Boeing was one of the earlier developers of software applications to do simulation. Boeing was one of the very first companies to develop their own spreadsheet and try and sell it on the open market. Lotus, if you used Lotus 123, that technology came from Boeing spreadsheets. So this idea of using the computer to automate and make tasks for engineering have been around since the early days. But the advent of the use of technology today has really changed a lot. And so I just want to start with a couple of comments about our company. We are a global company that has three primary business markets, if you will. Most of you probably know about the commercial airplanes. If you've traveled recently on an airplane, chances are that you were at or near a Boeing product. But we also have a defense, space, and security business that sells both to satellite customers as well as governments. And then finally, we have global services, which is, if you will, our forward-facing support to our customers worldwide. And interestingly, when you have a business that's broken up into these kinds of segments, and you talk about the use of data and digital, you find that they have very different needs. They drive very different demands on what they need for digital and how that digital works for them. And I'll talk a little bit about what some of those differences are as we go through our talk today. Also about our company, it's as most companies are these days, it's global. Of course, with the kind of product that we build, that would make sense. Some interesting points here about Boeing, and the one that I would draw your attention to is the stat there on the supply chain. One of the things when we talk about digital and the use of the digital data is what is its impact from a supplier perspective. Recently, I've taken on some responsibilities to start looking at the supply chain in our company and the use of digital, and it's amazing the diversity of ability of where a supplier is to a company, especially in a large, complex supply chain, and how digital actually makes a difference in their life. So those 12,000 suppliers, if you will, give a complete end-to-end perspective of everything from no digital to you're not going fast enough, I'm ahead of you, digital. And so it's a really interesting perspective to think about when we talk about the value proposition of digital twin and where is it actually. So just to maybe set the stage for that, I commented earlier, right? We started with CAD/CAM, as many did in the 80s, even going back earlier than that. From a product perspective, we have been doing model-based modeling since then. And so, today, all of our products are digitally defined, and we're now moving into more advanced methods for how we model and link the data, not just from individual, if you will, product paradigms, but to multi-product paradigms and system of systems. What's really interesting about this journey is that we're continuously asking ourselves the question about what's the value of this data and how is it different from what I've been doing before. Again, recognize we have a long history of working with this model-based data. So we've come up with this sort of set the stage chart, if you would, about digital and digital engineering, which kind of helps set the stage for digital twin. So just a little bit about what our thoughts are. If you're familiar with the systems engineering principles and practices, you probably recognize the bottom half of that diamond as the systems engineering V, or the systems engineering life cycle. The systems engineering life cycle was developed at a time when paper dominated the engineering paradigm. If you were in college, you learned how to do things on paper. You did analysis with plot paper. You had a calculator and a pencil. Of course, we don't do that anymore, right? We hardly do that. Everything is now computing. But the paradigm of modeling still relies on that antiquated approach. So we looked at that and said, hey, there is a digital representation that needs to exist here, and we need to reflect it, which is the top half, if you will, or the green side of this diamond. And what's really cool about the top half of the diamond is not only does it recognize the fundamentals of engineering design and how it should be done, if you will, in a life cycle context, but it connects the virtual products that go with it. And now we begin to see opportunities. And so when we talk about digital twin, we're now able to dial in at each one of those data points and ask the question, what would a twin enable us to do at this point in a product's design? We also use it that way for, if you will, how the product is used in service. So you can see some of the benefits here in terms of being able to have this linked ecosystem, which we characterize as our digital thread, of our engineering work products, not only to create the product itself, but also to unlock the data and the ability to use that product in service and in different market conditions and for different customer uses. So we live in a connected world, and one of the things that I get involved a lot in when we talk about the use of this kind of data is how we link this data and link it holistically so that everybody can use it. And as it turns out, if you think about how a product is designed, and it goes from a market need to requirements through the design life cycle, you're adding intelligence and additional information to that product design at every step of the way. When you're done, you have not only a complete representation of the product, but you also have all of the lessons and incorporations of everything, the decisions that took you to get to that product. We like to call that our living in a connected world, and these models and how they relate require standards, which I'll come back to time and time again, require standards to be able to use the data and for that data to flow without restrictions. One of the things that when we talk about digital twins and the thread is the relationship of these data elements to each other at the standard level. Without this level of interoperability and federation of these models, our experience is you build models that you can't sustain. They become simply too complex and they take too much energy to maintain. But if you're able to, if you will, partition these models and create that digital thread with these as a function of life cycle, you are able to create something sustainable for your customer if they're asking for them, but also for your supply chain customer who needs to build product for you. So with that, I just wanted to set the stage with a couple of thoughts about how this looks from the aerospace industry. And thank you again for remarks today. Thank you.
Yes. Thank you very much, Kenny. Thank you for sharing how you work at Boeing and how it works in the aircraft industry. So then we have our next presenter here, and that is Fergal Odonka. Yes, and you are the Senior Research Scientist and Technical Lead at IBM Research Europe, and you're placed in Dublin, Ireland. And I know that one of the key aspects that you are working on at IBM is digital twin. So we look forward to listen to that.
Great. Thank you, Charlotte. Perfect. So what I want to do today is give a digital twin perspective from the work that we do in IBM, because I guess a little different from the previous speakers that are very focused in terms of air industry domain, etc. At IBM, we work and provide technology across a lot of different domains, industries. So whether it's asset management, whether it's supply chain, whether it's different industries such as telco, electrical and utilities, transport, etc. And what I want to focus on is two things. What we learn working across these different implementations, instances of digital twin, and the emerging opportunities, technologies, etc., that we're seeing in that space. And I guess in particular, what I want to touch on there is the role of large language models, foundation models, the ChatGPT style or Gemini style models for digital twin. I'm going to start very quickly with, okay, what do we mean by digital twin? So I think there's 2 points that are important to emphasize here is, number one, the bidirectional aspects of it. So there's a physical twin and there's a virtual twin. And there's a bidirectional feedback there. I think it's important to emphasize as well, that feedback doesn't have to be instantaneous. It's not always actuator based. It can be, going back to Boeing, it can be you have a digital twin of a plane that is informing post-flight activities. It can be many different approaches. And the other aspect is a digital twin informs what-if scenarios. It informs decision. Essentially, a digital twin has predictive capabilities. We can explore into the future, or we can explore across different scenarios with a digital twin. The other thing that I want to highlight is there isn't a single, for a customer, for our end users, there generally isn't a single digital twin that we don't have a digital twin, and then X days later we have a digital twin. It's iterative. There's different levels of maturity. It very much starts off what problem are we trying to solve, and what value is digital twin providing for us from a product perspective, from a service perspective, and how do we achieve that? And by focusing on from a digital twin maturity perspective, and focusing on how we can iterate in a changing, evolving environment, it provides a more achievable digital twin perspective. And when I say a changing, evolving environment, one important thing here is data, information, etc. The data that's being collected in any organization, it evolves over time. There's evolving data collection approaches. And it's critical that we have a framework that is adaptable to those. I want to touch on one example that we're currently working on from a digital twin perspective. So this is part of a Horizon Europe project called Digital Twin for Green Shipping, which focuses on the decarbonization of the shipping industry. And from a decarbonization of an industry such as shipping, there are many technological approaches, such as alternative fuels, etc., that are at different levels of maturity. But the opportunities from a digitalization perspective and the opportunities for enhanced efficiencies that digitalization provides is a extremely promising avenue here. And from a digital twin perspective for shipping, there's three components that are critical to that digital twin. There's a data space environment where we are collecting and bringing together the myriad of data coming from a ship, whether it's sensors, whether it's cameras, whether it's noon reports, logs, work orders, etc. There's the semantic aspect of how do we translate that information from different sources into a standardized, accessible format. And there's a model library and a model execution engine that allows us to run predictions, run scenarios on those data, etc. as well. And from a digital twin perspective as well, one important aspect from a shipping perspective is the critical role that Edge AI plays there. Edge AI essentially means that computing is taking place somewhere away from a data center, away from a cloud, closer and near to where the data is being created. We see that across a large variety of instances. The most obvious there, for example, is mobile and computing that happens on your mobile directly where data is being collected. For shipping, it is absolutely critical that we have the capabilities to compute, execute, and apply our digital twin in areas where we don't have connectivity, etc. One other aspect that I want to touch on is the evolution towards composite and connected twins, where we have multiple twins interfacing with each other. We can consider, for an example here, you may have a product twin that is evaluating the performance, efficiencies, and evolution of a product. You might have a related production twin that is tracking and monitoring the manufacturing process. You may have a distribution and supply chain twin connecting to the network aspects of that, so to speak. And within that connected or multiple twins, there's two key points that come into play. There's obviously the key importance of a collaborative and multidisciplinary aspects where we have the ability to connect multiple twins seamlessly, and where we have oversight of how they connect, and the other piece then is how we instantiate and ensure trust and veracity across those composite twins or connected twins. And what becomes very critical there is the very classic aspects of verification, validation, and uncertainty quantification. How do we ensure trust in the digital twin, and how do we quantify the expected performance when or what are the assumptions underlying those, and when can we expect them to perform well versus when do we need to proceed with caution, so to speak, or when do we need to explore further there. What I want to touch on briefly then related to the digital twin aspects is across every industries we're seeing now that foundation models, large language models, they're really disrupting a lot of across a lot of domains, industries, etc. And from a big perspective they're disrupting in the way we access data, they're disrupting in the way we interface with data, and they provide tremendous capabilities to interface with data in different ways. So it very much started off with language and the different, whether it's Gemini, Claude, ChatGPT, different models there. But we're seeing it also across image data, across time series data, across code, that they provide, that they bring the capabilities to interface with data across a very different manner. And one of the key aspects that they provide for digital twin is across three different approaches. So one is around the unification of data integration. So if we consider digital twin across many different domains, industries, there's generally things like IoT data, there's generally things like visual data, and then there's a lot of reports, work orders, different manual specifications, etc., in different structured and unstructured sources. Large language models, foundation models provide tremendous capabilities to interface with that data in a more unified, scalable approach. The other approach that it provides is in terms of the scalability and flexibility that it enables, and that is very much across, can we move more rapidly from the data integration step? Can we move more rapidly and act on data in a more rapid manner? And the third piece, which is extremely important from a digital twin perspective, the ability to incorporate domain knowledge, which is fundamental to any performant or well-performing twin. The ability to incorporate information from articles, the information from logs and reports, the information from different company documents, etc. And where we're seeing that really playing out now is what's sometimes called large language model powered agents, what is sometimes called scaffolding for large language models. And what that in effect means is with the evolution of these foundation models, they have the capabilities to access a lot of external tools. So we see it in terms of the ability to access the internet, the ability to access access external functions such as calculators and APIs, the ability to write and execute code. So we can see that there's a tremendous opportunity to streamline how digital twin interacts with different components of the twin from the perspective of information that's accessible from the twin, information and models and simulation capabilities that are available within digital twin capabilities, and how information and insights from the digital twin is surfaced to the end user, whether it's through user interfaces, and whether it's through conversational agents, whether it's through generating written reports, etc. And some examples that we're seeing here, I think a few of these are from our consulting unit. Some examples that we're seeing is the user can interface with the twin in a natural language query, and what we want the digital twin to do in that instance is correctly identify what the user wants to achieve from this query, and to correctly identify what capabilities, tools do I have available to act on this query, so that it isn't the information that's generated by in response to this user query, it isn't coming from the pre-trained knowledge of the foundation model, but it's instead coming from the tools and capabilities that are available to the twin. So we can consider it, if we consider the first one of optimized traffic flow in downtown area for the next 24 hours, we can consider a data retrieval and API perspective and API function calls. The ability to run optimization simulations, so the ability to query and run models within the digital twin, and the ability to take that structure return and generate a output that is returned to the user in the manner that the user is expecting. So that can be, in this case, it can be a traffic management plan. Another approach can be, for example, if we consider exploring the impact of adding a new wind turbine to a farm, the output there can be a report generated on the learnings and the outputs from a simulation engine that is automatically configured and run by the user. And if we consider today how we interface with Gemini, ChatGPT, any ones that you use, it's very seamless to ask the model to refine what is generated, and in a very similar manner, it is very easy to refine the outputs and the generated reports from a digital twin perspective here. If we consider that last example of adding a new wind turbine to an existing wind farm, if the user wants different configurations, we can very easily modify those configurations and rerun the simulation. And that is everything that I wanted to discuss today. I hope it's raised some thoughts.
Yes. I'm sure this is raising some questions for all of the nice presentations. So hold your questions. There will be time for those. But before we open for discussion, we have one more presentation, and that is from Ulf Karlsson. And you come from Xylem in Sweden. And you are the Director of Innovation for Xylem Water Infrastructure R&D. Yes?
Correct.
So I'm sure we will hear a lot about water and water treatment.
Yes.
Welcome.
Yes, absolutely. No, so Ulf Karlsson, it's great to be here, and I'm impressed by the presentation so far, and I've done some reflections here. We have transportation as a theme, and we have Scania, and we have Boeing transports. We also have transport within Xylem. We have our biggest business segment. It's called transport, and we are transporting wastewater from the producer to the wastewater treatment plant. So that is our transport. So we are doing transport too. But I think that we are, the least known of the companies here today. So my presentation will contain a bit more about what we do. And to give you a little bit of a clue, our tagline, the company tagline is "Let's solve water." And water is something that many of us really take for given. We turn the knobs on the faucet and we get clean water, hot or cold, and we get rid of the waste all of us are part of producing. And we press the button and that disappears magically. But there's a lot of things around that you will see in my presentation. So let's see here. So that was the first slide that's coming up here, the company tagline. And then the next one is, we consider us to be a large company. We're not, as I was comparing to Kenneth, your numbers, we're basically a tenth of the size of Boeing, but still $7 billion in revenue, 23,000 employees, and we are a global company. We have water technology products and solutions in everything that is part of the water cycle. So it's moving wastewater, it's supplying clean water to us all, it is treating water. We are in many industrial segments, mining segments, power generation. We are in a lot. And we have a big piece of the company is we have a Swedish legacy. We have the submersible pump. That is a Swedish invention from 1947. And we have a big factory in Emmaboda, Sweden, about 1,500 employees, a big employer with Swedish measures in the south of Sweden. And that Flykt pumps, designed in Stockholm and manufactured in Emmaboda, that Flykt pump AB was purchased by ITT Industries in 1968, and we have been US owned since then. And these are challenges that we all face and that we are part of solving. We have steadily declining supplies of clean water. We have fundamentally ineffective infrastructure. If we take clean water distribution, to give you some facts, 20 to 30% of the water that is produced is lost. And technology, for instance, digital twins and other technology can absolutely help us to improve on that. And then the resources we have on clean water, those are easily contaminated. By industry, saltwater intrusion, that is a challenge for us. And then, of course, we have the unpredictable, the climate change and unpredictable weather that are affecting a lot within the water cycle and also in the transportation and charging networks, I'm sure. So, what we do, we are in the complete water cycle. And if we take it on a higher level, resource abstraction, that is around that is around producing energy, water turbines, power generation. It's also about seeing wastewater as a resource. We produce fertilizer, biosolids out of waste. We digest biosludge and produce methane gas. So biogas, I'm sure you heard about that. That's a big thing from the energy side. So buses in Stockholm are going on biogas. Drinking water production. So you take water from a freshwater source, you filter that, you disinfect it, and you distribute it. That is what that is about. And then the biggest segment we have is wastewater and stormwater collection and wastewater treatment and reuse. Some of the challenges in the small pictures I talked about already. One of the big challenges in society is for sure that operating water and wastewater networks is labor intense and it is expensive. And here is where we are part of the Digital Future Corporation here with KTH and the City of Stockholm, and we are targeting to address challenges around how we can more effectively work with everything within the water cycle using digitalization and digital twins as a key. Our digital twin definition it's going to be similar to what we've seen so far. It's an integration of data and a model that helps us understand how an actual asset, system, or process should be operating and or will operate in the future, as well as how a future asset, system, or process will perform. So very similar to what's been presented so far. And then if we go into wastewater networks, if we take it in the lower part of the slide, we have a lot of infrastructure in society which is around wastewater, and we have residential areas typically where we produce wastewater. It flows with gravity to a pump station that we have millions of pump stations globally. There, in the pump stations, we have typically 2 pumps for redundancy, lift the wastewater up through a force main and then to a drop point, and then it falls by gravity again, often to another pump station. And then once you move towards a wastewater treatment plants, the pump stations typically gets larger and larger because it connects a lot of the connection system together, coming closer and closer to the wastewater treatment plant. And to the upper right, you have an example of just have a collection system and a typical sewer pipe network, how that can look like. And the use cases for a digital twin within wastewater is sustainability, energy reduction. There is a lot of energy used for pumping. If we take global numbers on pumping, it's 20% about are used for pumps globally of all the energy that is produced globally. So that's a big number. And for the water and wastewater side, it's in the percentage range, 3-4%. Hard to get an exact number, but it's significant. Other use cases, inflow and infiltration, that's a big problem. So predict and detect inflow and infiltration, that's a good digital twin use case. Overflow, when the flow gets too much. You have extreme weather, you get too much water to take care of. Then you have a system that just can't handle it. You will get the overflow. That can be prevented, and if you have an overflow, you need to predict and quantify that. And then lastly, hydrogen sulfide. That is a gas that is formed by stagnant wastewater, and by operating a system smart and not having stagnant zones, you can predict and prevent the forming of that gas, which is a harmful gas. So everybody that are out, operators, they have a gas meter typically on them, and if the level is too high, then they are not going in and doing a service job. So that's how that's working. And then a couple of examples. We have a network optimization utilization system. So this is a simple example. It's more, but it's to give us a good picture. You see the different different, wastewater lines are illustrated, and you have 3 or 4 areas, and you see in the backdrop, you have think about a city layout, a city area, and you see there in the upper left corner, there's a rainfall coming. So we have rainfall starting, and we have a system that basically have 3 agents, optimization agents, and you see also that you have a tank located in this, and you have a wastewater treatment plant. And this system is working out basically a supply and demand model. So if you have a low demand, then you have a pricing model that's a low price to send flows, for instance, to the wastewater treatment plant. So what happens then if you have more flow coming into the wastewater treatment plant, then the agent for the wastewater treatment plant says that now I need the price is going to be higher to send flows to me, and then the model will adjust accordingly. So you see where you have the rainfall, that agent is going to start filling up that tank and sending some of the flow further on to the wastewater treatment plant, and and agent 1 and 3 will basically start filling that retention tanks, because it's the price indicator for that tank is low. So this is something that we have implemented as part of our solutions for prediction and preventions for say city water infrastructure. And this is a case from city of South Bend, which is in Indiana, United States. And the city of South Bend, they had a challenge that they were, on average, they had an overflow of 1 to 2 billion gallons of combined sewer overflow into the St. Joseph River, which is in that area. And the city was faced that they needed to do an $850 million investment in the water infrastructure. But by implementing, our optimization solutions and predictions, they have been able to scale off $500 million of that investment, because they can operate the wastewater network much smarter and prepare for a weather event. So that is a really good case. And they have also, the investment in the water infrastructure has also been cut down to basically a third of what was initially projected. Other real-time what-if scenarios that we have within the clean water distribution is real flow simulations. What happens if you have a pressure loss? Aging infrastructure, you have quite a lot of poor infrastructure, so systems that can simulate what happens if a pipe breaks in this area, what will that do to the pressures in other parts of the city? Source region, where does the water in the tap in a certain place come from? And then water retention time in a city infrastructure. That is also central, because you do not want to have stagnant water. Lastly, I'll give an example of what we consider to be a true digital twin, and a perfect example of which checks all the boxes. And I would say that it's high on Fagall's maturity level, probably step 4, if not step 5. So we have real-time decision support system. So sorry for the acronym, but that is what it stands for. And it's a digital twin system that we call the optimizer, and it controls a wastewater treatment plant. It uses inputs, sensors for water quality, flow, and other parameters, historical data from the wastewater plant looking back 12 to 36 months. That's part of the decision base. SCADA, the real operational data. SCADA, that is typically a very common asset management system where you get basic parameters on your equipment. Energy consumption measurements and weather forecasts. Weather is going to be central. You're going to have rain, you're going to have a lot of inflow, you're probably going to have lower temperatures that affects the processes. And the outcomes is optimized energy usage, optimized chemical consumption, increased effluent quality, and flexibility to choose guided or automatic plant control. So I'm 2 minutes, yes. I'm going to be done shortly. So what we have done here is that we have a digital twin system of the wastewater treatment plant that is predicting and simulating and finding the best possible outcome for a set of parameter settings. And there's a lot of parameter settings in wastewater treatment that we can talk about maybe another time, but it's quite complex. But what the system does is that it finds the optimal setting, and then the user can then choose whether they want to manually accept this setting or if they want to go and have the system automatically set up the process for them. And we have 45 installations with this digital twin applications, and more than half of the users are now using the fully automated version. So then they have, and then the remaining part, they are basically approving the suggested or recommended settings from the digital twin. But more than 50% are going into the fully automated mode, and we think that this is a perfect example of a digital twin in society. So that concludes my presentation. Hope you enjoyed it. Thank you.
Yeah, thank you, Ulf. You could actually stay here,
okay,
because now I will invite all the 4 of you up here for a little bit of a discussion about societal use for digital twins. Yeah, you could just stand here along this table, and then we'll have some discussion about societal use on digital twins. Like all of you presented different aspects and how you are using them today, and also a little bit of future view and a little bit historical. And I'm sure this wasn't the same if we just go back maybe 1 year, or if we go back 5 years, maybe it was completely different. So how would you see that this concept has evolved over time, the concept of digital twin?
Yeah, I think I'll start with that one.
Yeah?
The concept of digital twin, early days when Boeing was looking at this, we had this idea of, well, this is just engineering with more data. Oh, well, we just want the data to come from the field and connect to an engineering model. So it was very, I'll say, singular focused on an extension of modeling that we were already doing. And we had this, huge debate inside our company about, well, the digital twin requires a physical thing before we can have a twin. So we had to go create the thing first, and then we said, well, there's the twin. Now, it's like, well, wait a second. Back to that diamond model, the twin can actually help us with selecting the right design parameters in the first place. And so the thing that's changed, I think, is opening the aperture, if you will, of all of the different alternative use cases that having a more complete digital twin paradigm brings, and how it can help product development and what the customer is looking for when we deliver that product at delivery.
Sounds a little bit also as the hen and the egg problem.
A little bit.
Actually coming first.
Yeah.
I think I would definitely agree with that. I mean, I think digital twin has been there for the concept's been there for many, many years, and it's been called many different things over the years. I mean, we started with simulation and data simulation, and we're seeing now that we're moving much towards a bi-directional feedback and the ability to actually do 2 things: the ability to tap into information across a wide variety of different sources, and the ability to communicate that, return that to the end users in a more natural and in a more directed manner across different aspects of the life cycle. So if we consider from a product perspective, we have visibility of how that product was produced. We have visibility of what the product does and how it acts during its life cycle, and we have visibility of where that product is across the distribution network.
Yeah, thank you. Yes. One more question to you, Fergal, because we heard a lot of different applications, and you are the one that is not so dedicated to just one application. So what do you think has been the challenges and lessons learned if you look at, over the different types of industries and application areas?
Yeah,
There's
certainly.
some common challenges.
Yeah, certainly. So I think one aspect is the variety of data that really has to be brought into bear to have a really capable digital twin, and we see that across water, we see that across cities, etc. There's the more obvious ones that immediately come to mind around sensors, cameras, etc. But what we're really seeing huge value is the ability to incorporate organizational knowledge into digital twin, the ability to encode that within a digital twin and make it accessible and make it more permanent within the digital twin rather than relying on individual persons to have that information. There's the breaking down of silos across different components of an organization is something that we see as being one of the biggest challenges from a digital twin perspective, but it's also the biggest opportunities because there are very few digital twins that exist in isolation. It can't just be the engineering group that is involved in that. It has to be the entirety of the life cycle. And we're seeing that by breaking across those silos, it provides huge opportunity from a end user and a value perspective. And I think finally then it's understanding the maturity of the product or where we're starting versus the digital twin itself. And I think it's the ability to start from now, build small and iterate rapidly on that to really tap into the potential of digital twin.
Yeah.
Yeah, I can add to Fergal's input here that, I mean, if we look at look on the water cycle, I mean, the wastewater and the clean water cycle also for that or products, then it's very clear that, I mean, customers and society are very receptive to, I mean, solution, digitalization, digital twins to help them to become more effective because it is a challenge. It's what has been historically that going by experience, we know that this part of the operation we need to pay more attention to this. Now it's much more a tendency that they want to lean towards decision support systems, much more so now than 10 years ago. And it's been a tremendous change when it comes to, I mean, if we start with the smart city and what you talked about, Magnus, I mean, the smart city and the data that we have available. I mean, we have so much more data available now, so we have much more to build upon, I mean, with making digital tools and digital twins to help us with the transformation.
I want to add one maybe contrarian view here.
That's fine. Yes, good.
Oh,
yes. Being that company with that, some customers say, "Give me a digital twin. I want your digital twin." And we're like, whoa, wait a second. Let's talk about this. What do you mean you want my digital twin? And what I mean by that is people are they've known it for years, but the more you model, the more you realize your company's intellectual property and really the secret knowledge of how things work are in those models. And now you want models of models to interact. So I'll just take an example, right, of a commercial airframe. We buy 70% of an airplane from a supply chain, of which about 50% of that is systems. And, those are provided by companies who, by the way, they don't sell just to us. They sell to the market. And when we say we need your full model representation of the performance and behavior of that subsystem to go into my system, they're like, no, sorry. I'll give you the product, and I'll give you the maintenance instructions, and I'll give you the 800 number to call when it breaks, right? But I'm not giving you my intellectual property that is in that product. And so as we start to dig into the expectations and the opportunities for what we see larger implementations of digital twin can do, this is turning into a real showstopper. It's like, nope, wait, stop. You didn't pay for that data. And by the way, that data is not available outside of our company. So now what are we going to do? It starts to reset, if you will, the conversation about, well, what are we really trying to do with this digital twin? And it's really starting to force us to rethink the role of the model in the representation of the product. Because that intellectual property it's real. It's something to protect.
Yeah, that brings us into problems that you can have or issues that you can have when you apply a digital twin and start to use it, and issues that you run into and that you have to solve. Looking at that a little bit more, what would you say are like technical problems that you run into when you start to apply digital twins? Are there any particular ones that are hard to solve or technical issues that are more easy? This one is one, for example.
Yeah.
I think one thing that we see quite a bit is it's critical that you understand the data, that there is a clear understanding of the data, where it comes from, what's the trust in that data, who created it, etc. And there's a critical requirement as we scale, and I think especially as we have twins of twins and etc. That there's a real the ability to analyze data as it's coming in, analyze the source of the data, analyze the context, semantics of the data, and the ability to make decisions related to those, so that there is there's trust and assurances in the data that's feeding into the digital twin, and also that there's a contextual understanding of how the different data relate to each other, when it's IoT, when it's visual, when it's logs, reports, etc. So I think that's one of the key aspects that we're seeing in a lot of twins.
Looking at applications like smart cities, are there also challenges here?
Yeah, I want to be the boring guy then, to be the but no person and say, but we're considering a lot, of course, regarding security and data integrity, as you mentioned as well. When we have a system that's in real time feeding another system, which in this case is a physical city, it's very important that this information is correct, or is at least as correct as possible. But also in the extension is I would probably know where, not only where Ulf is, but also where he is going. That is something that maybe not everyone should have access to, that particular digital twin. And it's more like when we talk about infrastructure today, usually being something else, is the digital twin also should be considered something worth protecting as much as the actual physical infrastructure. Yeah. I promise to remove my but no.
Yeah.
You should care about both twins equally much. Yeah.
But you bring up a really valid point. I mean, in my business, we call it cybersecurity, right? So the role of course, cybersecurity to protect all assets, but it's really important that you have trust in the virtual assets that you're using to make decisions with. So how you, if you will, instrument how you protect and how you augment from a cybersecurity perspective is just as important, on that twin as it would be to the physical product.
Yeah. So for sure, there are a lot of technical issues that are relevant and fun to work with. But if they weren't for business drivers, this wouldn't move forward. So what would you say are the major business drivers in this area for your application?
Yeah, I can take that one. So main business drivers, as I touched upon in the presentation, and we have a massive energy use. I mean, for our products and applications, and that is a key business drivers. I mean, all customers are working on sustainability and then trying to reduce energy use and carbon footprint, reduce that. So that's a key driver. And then also, if we talk about the operation of a city, all the equipment, how you do that effectively, that is a common challenge that many cities and operators are challenged with. So I would say that is those are the two biggest business drivers for our customers, and then for our company also, and at the same time.
I can add on to that also and say, like Scania, which our higher purpose is to be the driver of a sustainable transport ecosystem. And this is one of the true game-changing enablers to become more green in an easy way if it's used in the right way. So depending on how you see it, this is the enabler for future business for us. At least it's part of our core and part of what we believe in is our purpose as a company. So it's a huge opportunity for us.
Yeah, I mean, I would follow that as well. I mean, I think fundamentally, a digital twin, the objective is to use it to optimize and inform decision. But then there's the other aspect that we're seeing a lot with customers of institutional knowledge is extremely important to organizations, and there's a very real fear of and reality of losing that institutional knowledge due to people leaving, personnel churn, etc. And what we're seeing is a digital twin provides a key capability and driver to manage that and to streamline how people work together, to streamline how people work across different sectors within the organization, and to streamline how information and knowledge is managed across the organization. And that is, I think, one of the more unexpected or surprising drivers for digital twin that we're seeing.
For us, it's all about safety. For the aviation industry, the ability to use these digital assets to be better, to have higher quality, to find defects in thinking, defects in system design, defects in deployment, that we can find early on makes the entire system safer. And so we just see a huge, in addition to the sustainability, which is a big deal for aviation as well. I would have to say the safety of the entire system is probably the biggest driver for us.
Yeah, and I want to add to that also. I mean, if you remember the digital twin example of the wastewater treatment plant, you think about the effluent quality and then the risk safety in us drinking water with contaminants, not good at all. So the digital twin simulations that eliminate that risk. So absolutely safety is big for us as well.
That is also a societal concern.
Yes.
Are there other drivers from societal perspective? What would be the major benefits for society, you will say, to have digital twins of the different products or systems? Or
Can I start on the other end of that question and say, so if we would pretend that we live in a world where everything will become a smart city, the initial investment we're talking about is enormous. I threw around some numbers today, which was like 50 billion yuan, 6.5 billion euros, and we're talking about 1,000 different traffic lights being converted into digital, and a parking lot or two and some autonomous areas. So the government, in this case, if we talk about infrastructure for society in its form, they need to also be a driving part of this. And I don't think that maybe not a lot of societies are ready to make that initial investment, especially if you want to apply it in a smart city scenario where you actually use the twin data to affect traffic flows and other things. Today I took a few huge examples, but if we talk about smaller examples, how can we optimize our own factories or supply chains? There, of course, it's easier to make the business case of this type of optimization in the small case scenario generates this much more revenue in the end, or shorter lead times, or whatever it is. But when it comes to these big smart city projects, it's very difficult to see when will the business case hold, and when will it break? Maybe it will never hold. It's just an investment that you need to do.
Yeah, thank you. Thank you. Now I will switch the topic a little bit. I know there are many academics in the room, so if you just had a wish list for the academics, what should they be working on when it comes to digital twins? Are there some issues that are more important than, or maybe have more urgency in being solved?
I think one aspect that we're seeing quite a bit of is, so one at a high level is around the interaction of different digital twin, but I think related to that there's two important points. From a digital twin perspective, it's extremely multidisciplinary, and there's expertise across a lot of different domains. And so one example is data assimilation of the role of digital twin, which is a huge scope in the Earth systems community for many, many decades. The bidirectional feedback from digital twin to the end users, which the engineering domain has been working on for many, many years. Another very important concept that we probably haven't discussed too much is the human interaction with the digital twin, where if we look at different industries, the healthcare sector has huge experience across those, the human behavioral aspects related to digital twin. So I think that increased multidisciplinary nature of digital twin as they become more integrated, and I think related to that a very, I guess, old school concept of how do we validate, verify these digital twins, and how do we quantify the confidence in these digital twins? Because I don't think it's necessarily that a digital twin is correct the whole time or is accurate the whole time, but it is absolutely critical that we know what the assumptions underlying it, and that we know when it can be trusted and when it's operating outside the parameters it was designed for.
Mm. Yeah, I'd add just maybe a couple of lines to that, because I think that was a really good. I think that was a really good explanation. I think of the academic problem sort of as two things. One is research. We are now beginning to recognize the value, right? And we've talked about some of the value propositions here of having digital twins, a multidisciplinary approach. So more research around how the digital twin actually works with standards and the ability to interoperate with digital twins, but then also education, right? I mean, I doubt that there is a course at this university called Digital Twin Engineering 101, which speaks to the evolving need for students coming out of university to have some of these in their toolbox. Data analysis, data scientists, the engineering principles, the use of this in an economic or a societal view. These multidisciplinary views is something that an education system can put, if you will, the basics in, that then industry can use and run with.
Yeah, can leverage on that directly when the students go out and start to work.
Right.
Yes.
Right.
Yes. So you touched upon this now, Kenny, the importance of standards. And we also saw in the 5-level maturity model that the ultimate level is called autonomy. And then the twins should be able to speak with each other and coexist. So for purposes like that, standards are very important. And I know you are involved. Could you say a little bit what is going on?
Oh boy, what is going on? Which standard do you want to talk about? We have so many.
Sure.
Yeah. No, the community of standardization really has leaned into digital twin a lot. And so I work in ISO at a technical committee level, and there is entire groups in ISO that are working on standardization of digital twin. I'll say from two perspectives. The first one is, I'll say, an overall system view of digital twin. If you think about, and typically we talk about smart. So smart is attached to digital in some fashion, but digital twin and IoT seem to have an affinity to each other. And so in the standardization community, there's been a lot of connection from an IT perspective, of being able to enable, I'll say, basic functionality that works for cities, works for aircraft, air transport, works for other infrastructures. And then there are domains. So for me, I really resonate with the manufacturing and the engineering domain. And so the standardization that's happening there is around, okay, now if I take the basics of a digital twin concept and understand sort of at the data level, how do I apply it to my area? And there are standardization activities happening within industrial data, which is where I am at, but also in farming, in manufacturing, and so many healthcare. All of these are are developing domain-specific implementations, if you will, or standards associated with digital twin. It's a little hard to see because there's so many moving parts going on, but definitely the standardization community is getting on board with some of these concepts.
Yeah. And that's exactly what we're seeing as well. I think the affinity between digital twin and IoT is a very, very good example. And I think what we're seeing evolution now is that proliferation of digital twins between industries and what that means in terms of how data is reported across those industries, and especially how data other than sensor is managed, reported across those industries, and the trust and confidence in those data across the different industries.
Okay. I will just ask you one more thing before we open up for questions from everyone here, and that is looking into the future. How do you think digital twin will evolve, and what importance and impact do you think they will have for both your company and for society at large? Mm-hmm. It's not an easy question. No?
It's a scary one, though. It could be potentially very scary. But if applied in the right way and used in the right way, the opportunities both for society and all our companies and everyone that is doing business is enormous. And the benefits are enormous. But if used in the wrong way, we talked a little bit about security and the way that we need to handle maybe the digital twin of things, but also just by utilizing the data that the whole city collects in the wrong way could potentially be disastrous for a whole country if you really want to sabotage or destroy things. On the other hand, depending on what country you're in, it could also be a huge opportunity for government or for other parts of the governance of a country to actually keep track of not only where he is, but where he is going. So I see it both as, wow, this is something that we need to unleash and start to understand more and experiment with, but also sort of like, but we need to be a little bit careful what we are unleashing and what we are experimenting with, because it could go very wrong pretty quickly. Sorry to be that... destroyer of bad mood again.
No, it's you should be cautious.
I think it's certainly something that it is huge opportunity and huge potential for positive and negative impacts. And I think there's some things that are going to evolve, but will have the same principle base in terms of the importance of life cycle management of data, etc. And then there are new technologies that will evolve how we interface with digital twins. I mean, of course, we're seeing a lot around the metaverse now and what that means for digital twins and what that means with how we interact with digital. I mean, I was reading one of the Gartner reports there recently. I mean, I think if it looks in the next 3 years, the evolution of digital twin and at longer time horizons as metaverse capabilities and how we interact with those come into play, and especially across the different sectors, across transport, across smart cities, across healthcare, then I think there's huge evolution and opportunities and potential there.
Yeah, for aviation, it's a huge opportunity for us. The aviation business is capital intensive. If you think about not just building aircraft or space vehicles, you have to also talk about the airports and the spaceports and how you're going to get to the airport, how you're going to get to the spaceport, and everything that is involved in making that entire system function. Again, coming back to the point of safety, every incremental improvement you can make in safety helps the entire system get better. But also, there's an added benefit in that we are able to more optimally use resources. So in our business, right, it's very resource intensive to get to that first product. And the maturity of twins will enable us to evaluate more alternatives before we get to that first product and really save resources in the long term.
Yeah, and I mean, before we look forward into the future, if you think about where we are right now and the examples on digital twins that I presented, those are more I see it's very clear that it's in areas where we have more of a control. It's boxed in. I mean, within a wastewater treatment plant, we have all the products, we have all the system, we have all the process technology. So we can move into that space and be successful. But it's much harder if you go into the societal piece. I mean, a city where you have a lot of different suppliers, systems. We also know that the potential is much larger there. If you look into how you operate a city's hydraulic water pumping system, you can save tons of energy to do that in a much better way than we do today. And we need digital tools to get to that point. And that's where I expect that we are going to move into the future. So that's...
Yeah. Thank you. Thank you, Ola. I'm now curious to know if you are curious about something, if you have questions. We will have a mic coming down. Yes. There is a question here on the upper part and then down here.
Hello. Thank you for your interesting talk. This is a new topic for me. But I have a question. When does a model become a digital twin? Because model can be a very broad thing. Well, so what specifically makes a difference? Or is a digital twin a model, a very sophisticated model, but a model after all? What is the qualitative difference? That's my question.
I can start with that because one example that I heard a few years ago was we have a digital simulation, which is a model of a whatever. And then we have what they call digital shadows, which is a model with data simulation to some degree. So a model that is taking feedback from the environment. And then we have a digital twin, which is a model with data simulation that's also returning feedback to the environment. So it's that bidirectional feedback between that is critical. And I think there is also extensions of that. There was a recent report around the ability to impart predictive capabilities. But I think that aspect around the bidirectional flow is where I think about it.
Yeah, I would add to that. In the standardization space, we had this debate for close to a year of when's the difference between a model and a twin. And it came down to synchronization. So if you think about a model you can make of anything, right? So, all models are wrong, some are useful. And this one, the utility comes from taking your model representation of a system of interest and attaching to it synchronization with its environment. So you now are adding, either it's feeding in and you're just enhancing the model and because you want a better model fidelity or it has some other purpose, or you're feeding back out and it's giving you feedback so that you can act on what the model says. But the key point that we came up with when we talked about it from a standardization perspective was that synchronization with the environment at some rate. And that was key to us to be able to differentiate.
Yeah, thank you.
Hello, I'm John Barras from the University of Maryland, and I'm also a senior research visiting scientist here at KTH and the Technical University of Munich. So I work a lot with industry and I work in this domain, and I can tell you what the problems that I see are, and you can tell me from your perspective. First of all, thank you very much for your presentations and everything else. The challenge we have is that in large systems and systems of systems, and all of you talked about that, we don't have composability of digital twins. So you have a digital twin for some parts of the system, say for aircraft, for airports, then you have one for the aircraft, then you have for the transport. But we don't have a good way of composing it in such a way so that whatever requirements we put at the components, they can transfer to the overall system. So therefore, they can be useful for the main thing. The main thing you build digital twins, in my opinion, is that you want to understand what-if questions. If that happens, then what happens? And you cannot do that in the real system, but you can do it perhaps easier and faster in the digital twin. So that's the first question. And the second question that I have, which is interrelated, we looked at smart cities. That's a completely different problem because, to your point, there's not clear that there are only financial interest in social systems. There are many other systems. And there, the systems are larger. There are more different conflicting components and specifications. Let me give you an example that I'm familiar with. In the city of Portland, they tried to develop a digital twin to understand what happens dynamically during the day with respect to crime, so that they can actually make sure that wireless bandwidth is available in the areas where it's higher. All right, so that you can actually, if somebody wants to call for help, or if you want to tell police, and this was used actually in the allocation of resources for the communication network and the sensor network for the city to try to adjust. And there were many things happening there. And the most difficult one is that the environment changes dynamically. So you have to allow for these things, and therefore you have to incorporate the digital twin fast learning and how to adjust to that and do it at different scales. And this is very different in social problems like smart cities than it is, for instance, for a manufacturing production line where all started and so on and so forth. So I was wondering if you can give us some feedback in these two questions. What do we know about composability of digital twins? Because many companies will not share digital twin because they think this is my edge of competitive edge and I don't want to share it, okay? So how we can do this? How can we do composability, which is related to standards? And the second one, how we should tackle this problem with the cities and the social interests and the humans which we don't understand and so on and so forth, okay?
Yeah, those are some really great questions. I guess I'll try the first one. I'll let somebody else take on that second one because that one sounds really hard. The composability and the interoperability of the twins really is going to require us to rethink the infrastructure of standards. The interoperability demands of models we talked about from the point of view of exchanging data. Largely. We have computers here, we have computers there, we want the data to go from this computer to that computer, and we want it to solve some business problem, some technical problem. Now we want not only that to happen, but now we want to add on to it the flow of models that coexist with each other that are themselves interoperable. So now we've come up this scale, right? And I can tell you that the interoperability of models is a new universe when we talk about the kind of requirements that you have to have in place in order for models, right, which these twins are, to interoperate with each other and I'll say behave with each other. So it's a completely new adaptation of what we're doing today, plus I'll say an extension of more work needed in the modeling paradigm and how we build consistent models of these different domains of interest. Charlotta actually in her committee has a lot of these conversations around systems and architectures and how we use architecture practices a system of systems point of view. Trying to drag the moderator into the discussion here.
Any other reflections on these questions? Or
those are number two. There is a very good question. Yeah. Can't even try to address it on like this, but it would be interesting discussion actually to have. Yeah. Maybe it is also. I don't know anything about Portland for once, but it sounds interesting for me to look into. So. Yeah.
Yeah.
Mm. Mm.
Yeah.
Yes.
Yeah. Mm.
Yeah.
It's a very interesting topic that, of course, could have a big societal impact. I know we have more questions, so I would like to move to the next one.
So my question is, if you use the digital twin for operations, like you described, Ulf, for the water system, how big a challenge is maintaining that digital twin over time? And are there methods, tools to kind of automatically update when the water system evolves or is sort of extended?
Mm-hmm. Yeah, I mean, it's I mean, that piece is very much related to, I mean, what is the research and what is the development on how you I mean, physically, I mean, treat water and what is happening there and how do you apply that into your water system, and also very much depending on, I mean, treating water is very much depending on regulation. So regulation can come in and state that all of a sudden we need to treat water on some medical residues, I mean, in water, and then that would then, of course, affect, I mean, the treatment process and needs to be implemented in the model and the digital twin to address that. So, but the frequency, I mean, it's a continuous work. I mean, that would be it's a hard question. So that would be my answer. Yeah.
Maybe if I could just add on, the twin should have the same sort of investment focus as the product itself. So if you plan on putting a twin in the market and leveraging its value, then of course you're going to need to provision for it, right? So in the airline business, one easy example is engines for commercial aircraft. They're all leased. No airline owns the engines that are on their planes. The leasing of those engines, the digital twins to the serial numbers of those engines are maintained by the engine manufacturers. And they've built an entire service infrastructure around making sure they know what those engines are doing at any point in time. So it becomes part of running the business on the utility of the twin. Where you get sort of in trouble is if you have this twin sitting out here and it's sort of not connected to the business, it quickly erodes, right? Because resources start to move away from it.
Yeah, we have time for one last question.
Yeah. Thank you very much for the very interesting talk. I remember one of the previous questions was about the model. And I actually have a question related to the data. Because since data is like a key ingredient for the digital twin, so my question is, like, in comparison with the data that used for parameterizing a model, what's the key property in the data that's used for building the digital twin? So is it, for example, is it amount of data that's the key property that make this digital twin possible, or is the diversity of the data that makes the digital twin possible, for example?
I mean, I can start with that. We're seeing that diversity of data is critical. I mean, in particular, what we see fundamental across many use cases, visual data provides a huge data. So visual and IoT data provide huge sources of data to guide, develop digital twin. And the third piece then is around a contextual or unstructured data that provide additional context to those. That in many applications that is logs, reports, work orders, different data on the status of the physical product, etc. But it's that fusion of IoT sensor data, visual camera, etc. data, and logs, reports, documents, etc. that provide that a contextual basis for digital twin across a lot of use cases.
I think I would add, in addition to the diversity, you have to have a mechanism for knowing the quality of your data. If you can't trust, the biggest, I'll say the single biggest thing I see with people trying to use our data for digital twin purposes, particularly when that data was generated for some other purpose, is quality. Quality of the data and its ability to support the use case that you're talking about, particularly if it wasn't generated with that in mind. So having a really clear understanding of the quality of the data that you're working with and where it came from and can you trust it, is probably one of the single biggest objectives around digital twin that I see.
And I can add too, I mean, on what we see in the water sector is that as recent as 5-7 years ago, then the data scientists working with developing on this model were a bit disappointed because we did not have the quality of data, the high frequency measurement points. So it could be a measurement point on 1 parameter per second or per minute, and it's just there's too few data points in that time series. So now what we have seen is that we have developed into having much more high frequency data with the evolution of IoT and sensors. So it's just we do not have the data limitation factor anymore. So then it comes down to the use cases and what are you trying to do, where we have a real challenge, collectively to find the right use cases and to solve the societal problems that we are facing. But my key point is really the frequency and data. It's a big transition that has happened in the last 5-10 years. Yeah. It's not. No, absolutely. No. Yes. 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 Absolutely. Yes. Yes, absolutely. Absolutely. Yeah. Yeah. Yes, absolutely. It's an excellent point. And then, now we have a cooperation with the city of Stockholm, and then what we are really stressing on the facing the challenges is what are the key problems that we need to address and solve. And then the second question is what are the use cases for addressing that problem, and what are the parameters we need. And ideally, those should be relatively few and not a lot of data. So excellent point.
Yeah. And with that, I would like to close the session because we are approaching time. And I would like to thank our speakers. So Magnus, Fergal, Kenneth, and Ulf. Thank you very much.
Thank you.
Thank you.